Hi, Sevies. Mr. McConaughey here. We're going to go over and review the Chapter 3 material before you come back on Monday. I hope you're having a good break. But based on the quiz results that I've graded so far, we need to do some review here. We have four main points that I want to cover. One is like terms. What are like terms? How to do the distributive property, one-step equations, and then solving two-step equations. So the first thing I want to cover is the definition of what like terms are. So like terms have the same variables and the same powers. So let's look at these three pairs of terms and determine if they are like terms. So the first term here, our pair, 4x and 12x. Do they have the same variables? Yes, they both have x terms. Second, do they have the same powers? Yes, they have the power to the first power. So these are like terms. Second pair, 5y and 7. Do these have the same variables? Well, we have a y term, and then we just have a constant, 7. So no, these are not like terms. You cannot combine them. On the quiz, I saw many of the students trying to add 5y, as an example, 5y and 7, and trying to say that that equals 12y. It does not equal 12y. Next pair, 3x squared and 4x. Do they have the same variables? No, they do not. Well, they have the same variable, but they don't have the same powers. Here we have a square, and here we would have a first power. So these are not the same powers. You cannot add or subtract these. They are not like terms. You've got to get that concept clear, guys, because this is key for the rest of the year. You've got to understand same variables, same powers, like terms. Okay? Okay, the second point, distributive property. Now, one of the things that I saw on the quiz so far is that many of you are not writing the rainbow symbol. And I know it may seem a little silly, but I really want you to do this, because every person who did not write the rainbow symbol did the problem wrong. So let's go over the distributive property. The distributive property here would say that we would multiply the term that is outside the parens times each term inside the parentheses. And that's why I draw the rainbow. So we are going to multiply 4x times 3x, and then we're going to multiply 4x times negative 7. Remember that sign. Okay, so 4x times 3x is 12x squared. Remember, 4 times 3 is 12. X times x is x squared. 4x times negative 7 is negative. 4 times 7 is 28, and then we have the x. So that is 12x squared minus 28x. We cannot, again, cannot combine these terms. These are not like terms. We have an x squared, and we have an x. You cannot add those. So you would be done at this point with this distributive property. Let's do another example. Okay, negative 3x times 4x minus 8, that quantity. So again, we draw our rainbow. Negative 3x times 4x. So we have negative 3 times 4, negative 12. X times x is x squared. next term. We have negative 3x times negative 8. So we are going to have negative 3 times negative 8 plus 24x. Okay? If you'd prefer, you could have written this as negative 12x squared minus negative 24x. I think that's more complicated. I think it's easier to look at the negative, and negative times a negative is positive. You have two ways to do this, but I think it's easier to look at that negative times negative and call it positive. Okay? Distributive property. All right, the next group, one-step equations. Again, this means that we're going to do one operation to solve for x. And again, we want x to be by itself on one side of the equation, and we want x to be positive. Okay, so for the first one, if we look at this, we have x plus 17. So we want to do the inverse operation. The inverse from addition is subtraction. So we want to subtract 17, and again remember, from both sides. So when we bring this down, plus 17 minus 17, that's 0. We have x equals, what is 5 minus 17? You've got to know that addition and subtraction. That's negative 12. So our answer is x equals negative 12. Now for our next one. This one is a little more tricky. We're dividing here. So the inverse is multiplication. But remember, we have this negative sign in front. We want a positive x. So the way that we're going to cancel out that negative sign is to multiply both sides by negative 7. So negative 7 and negative 7 cancel to 1. We have x equals 3 times negative 7 is negative 21. Now how can we check that? Remember the check your work. Let's substitute x equals negative 21 in for the original x here. Negative 21 divided by negative 7. Is that equal to 3? Yes. So that's the way that we can check. I guess I should check the first one here too. Negative 12 plus 17. Does that equal 5? Yes. So that's the way that we can check that work. Okay, two-step equation. Now let's look at the similarity here between the one-step and the two-step equations, because the first thing that we want to do, remember, is, or our ultimate goal is to get x by itself. Now if we look at these two equations, these look very similar. We're subtracting 7 on both of these. However, our difference here is that on the equation on the left, we just have an x. The equation on the right, we have a 4x. However, we still want to attack these two equations in the same way. The equation on the left is a one-step equation, and we would add 7 to both sides, and we would have x equals 12, and we're done. Right? If we check that, 12 minus 7 equals 5, and sure enough, that's true. So for the two-step equation, we still want to add 7 to both sides first. Okay? Don't divide by the 4. You can do that, but it's so much more complicated. Add the 7 first and get your x term by itself. So now we've got our x term, 4x equals 12. Now we have a one-step equation where we need to divide. So we're going to divide both sides by 4, and I want you to write it that way, using our division sign. okay? The 4's cancel to 1, and we end up with x equals 12 divided by 4 is 3. Now let's check that work. Substitute the x into our original equation. 4 times 3 minus 7. What is 4 times 3? 12 minus 7. So we've got 12 minus 7 equals 5. And sure enough, that works. Okay? I hope you're having a good break, and I hope this is helpful to you so that you come back on Monday and you haven't forgotten everything, okay? And you take care.